Welcome. In this lesson, we're going to learn how to find the center of a hyperbola. And let's actually talk about what a hyperbola is. A hyperbola basically looks like two parabolas that are symmetric about a certain point. The point they're symmetric about is called their center. So again, you might have two parabolas, which is actually called a hyperbola, that are opened left or right. You could actually have one that's opened up and down, like this one, up and down. These dashed or dotted lines that they're showing, what those are asymptotes. The parabolas gets closer and closer to that line, and we'll talk more about those in a later lesson. But for right now, just realize that those two lines cross also right at the center. And these points right here, the closest 2 points between the two parabolas or hyperbolas. They're not parabolas. I keep saying parabolas because they look like parabolas, but they're not. It's a hyperbola, but the two closest points are called their vertexes, the vertex. And what's nice is the center of a parabola is right in between that line segment here. Its midpoint is always the center. So if you can see the two vertices, you can find the center. All of these so far have been centered at the origin being 0, 0. Now, obviously, we don't have to have parabolas centered at 0, 0. So I'm going to jump ahead, and hopefully we'll see one that isn't, like this one. This one's centered at the point -4, 0. So, and these first few lessons are going to be very simple because they're going to show you the graph. They're going to show you those lines, those asymptote lines, and where they cross is the center. But even if they didn't show them to you, you get the two closest points and find the midpoint between them. So again, I'm going to jump ahead here. Now, this is the equation of a hyperbola. Now, equations of hyperbolas look almost exactly the same as the equation of an ellipse. The only difference is it will be a minus in between and not a plus. So ellipses, it's a plus. Hyperbolas, it's a minus. And other than that, they look exactly the same. So their center is always going to be this horizontal shift about their center squared over a squared minus, in parentheses, y minus the vertical shift squared over b squared equals 1. Now again, it might be flipped in the sense of you might have the y squared first. And the reason you might have the y squared first is because they will always put the a or the a term in front because the b term is always the one that's being minused. And I'll talk a lot more about that in a later lesson. But for right now, just realize that you only see it, that's supposed to be a minus k squared over b squared equals 1. So just realize that the y squared might be in front because the minus is always in between. So again, to find the center, I just see what shift's been done to the x and the y term. There is no shift. There is no minus h. There is no minus k. The center is 0, 0. But if I had seen parentheses above those fractions with the number next to them, remember it's always kind of the opposite of what you see. So again, I'm going to jump ahead and ahead again because so far, now here's one where you'll notice though the y's in front. So don't confuse that with the horizontal shift. My x or horizontal shift is 0, but the vertical shift of my center is -6 because it's the opposite of what you see or what makes this term 0. -6 plus 6 is 0. Again, I'm going to jump even a little higher really quickly. Hopefully get a shift of both the x and the y. Yep, right here. So we have a horizontal shift of -5, a vertical shift of +5 for my center. Here it's the reverse, the y's first. So we have a vertical shift of 7, because there's the y, right? Watch your variables, and a horizontal shift of -9. That simple. If you have any questions, please bring them to class, and I will help you then.